Welcome back to Half Moon Tech Labs. Today we're going to talk about automotive 12-volt relays used in vehicles and how you can use these to control large loads inside your car, including aftermarket devices that you may want to install. Light bars, amplifiers, things like that draw a lot of current that you may not necessarily want to route through a switch, which you've chosen to wire into the dash or in some place where you can control that device. Relays are nice because relays are actually switches that are controlled by another switch, okay? And so you can use a little tiny switch and a small amount of current to turn on a relay, and the relay will automatically switch the large load for you. And all the current handling capacity is taken care of by the relay instead of the tiny switch. So you can have a nice little decorative switch. I'll give you an example. Again, light bars, amplifiers, things like that. A friend of mine had he has a car. It's a performance vehicle. He wanted to put Recaro seats, these aftermarket racing style seats in his performance vehicle. And the problem was the seats have built-in lighting on the seats. And he didn't like how they behaved stock. If he just plugged it into the wiring harness, it either wasn't going to be compatible or wasn't going to work the way he wanted. I can't remember, but basically he came to me and said, "Hey, you're into electronics. How would you go about this if you wanted to have it controlled by something else?" And not only that, I'll throw in a little caveat here. He wanted not one, but two different inputs from the vehicle to be able to control a single relay. Now, that's a little trickier, but it's actually very easily done. So what I've done here is I've kind of recreated the circuit that I described. I'll show you the schematic here in a second. It's right here. I'll show you that. But more importantly, we have a power supply. This is a DC power supply. We're simulating a 12-volt car battery. This is set for 13.8 volts DC. The power is coming into this little breadboard that I set up. And I'm using a fan with LEDs on it just to simulate a 12-volt load. This can be anything. You would upsize the relay to control whatever load you really wanted to control. So if this was, you had 20 amp light bar on your vehicle, or you had a big honking audio amplifier that drew 50 amps or something like that, and you wanted to switch that and also have a level of isolation by using a little tiny switch to control what is essentially a much larger switch, in this case a relay. The relay will do the heavy lifting and take care of all the current handling capacity requirements for said load, whatever it happens to be. So you would size the relay appropriately. Here I used one I have down in the workshop from some other project. This is a 12-volt coil, and the coil wires are here and here. These 12 terminals you see here are actually 4 different independent switches that are controlled by the electromagnetic device inside this relay. These are essentially solenoids that pull a switch open or closed, and they're controlled by a small current, in this case 12 volts. So by using a small button, you see this little tiny push button here? This thing is meant to switch just very, very small amounts of current. So how do I use this to control a much larger load? In this case, the fan's not a huge load, but we're just simulating a load. When I push it, you'll hear the relay click, and you'll see this come on instantaneously. Watch. Okay? So what just happened was the 12 volts, the positive side, comes down, and it goes basically through the switch and into one terminal of the coil on the relay. The other side of the coil is grounded. It goes back to the negative terminal of the battery or to the chassis of the vehicle, either. They're at the same potential. And so now what happens when you press it, you're basically completing the circuit. You're sending DC through the coil, back to ground, and you hear the relay go click. Well, inside the relay, again, there are multiple little switches being controlled by that electromagnet that you're controlling here. So what's happening is this is a 4-pole double throw relay. We're only going to use 2 terminals on this right now, just the common terminal and the normally open, just to control a single device. You can use these to control multiple devices. Most people will use it to isolate and control a very large single load somewhere. So anyway, let's walk through this. So here's the circuit, because a friend of mine contacted me recently and said, "Hey, you're good with electronics. Can you walk me through how you would use not one, but 2 different independent inputs to control one relay to switch a load. In this case, he had Recaro seats. These are performance seats. They're basically racing style seats. He has a performance vehicle, and he wanted to put these aftermarket seats in that have these lights inside the seat. And to each his own. That's to him, he really wanted that, and so to wire that up to the vehicle and have that behavior where, in this case, one input I think was going to be from his dome light circuit. So in other words, when he opens the door to the vehicle, any of the doors, the dome light comes on. Well, the interior light circuit that comes on would be one of the inputs that would trip, that would supply the energizing current to the coil on this relay. But he also said, I want to be able to do that if my parking lights turn on too. So, but he wanted to make sure those two circuits are isolated from one another so there's no weird interaction in the vehicle. Like you wouldn't want to turn on your parking lights and have the dome lights come on when you didn't expect it, or vice versa. And not to mention that could lead to some pretty bad behaviors inside the vehicle or some electrical issues, including maybe a fire. So you don't want to do that. So how do you isolate them? Well, the solution was, I told him, I said, well, what you want is you want to create what's called an OR function at the input to the relay. And so by taking two different diodes, and that's what this symbol is for. This is for a diode. In this case, I've just used silicon rectifiers. These are just 1 amp, 400 volt diodes. They don't have to be that high in voltage. For automotive use, 50 or 100 volt diodes are fine. I know you're thinking cars are only 12 volts. Why does it have to be that high? Actually, it's very typical to find 50 and 100 volt diodes. So they're pretty easily found out there in the wild, and they're dirt cheap. So these are 1 amp diodes. Diodes are essentially a one-way check valve for electricity. So it can only pass from, so in this case, the diode, this is the positive side of the diode, and this is the negative side. So this is the anode side of the diode, and this is the cathode. The cathode has the line on it. So regardless of what you remember from school, or if you've heard, it goes from positive to negative or negative to positive, it's irrelevant in this case. As far as the math goes, it works the same. But when it comes to writing these schematics, then the orientation does matter. And so in this case, because it's a one-way device, it goes positive, let's just call it positive flow. So the positive input, in this case, the plus 12 volts coming from, in this case, the dome light, or let's call input 2, the parking lights, they're going to pass through the diode harmlessly. It's a one-way check valve. So basically it will be allowed to go from positive through the diode. It can't go back up this way because this one is in the same direction, same orientation, and it cannot go up through this diode because it's facing the wrong way. So these two, even though either can pass power to the coil, which energizes the relay, one, the other, or both can be turned on, and they won't see one another. They won't interact with one another, but the coil will see it. Now you may have noticed, if you have a sharp eye here, that there's a third diode right here, and it appears to be in backwards. That's this guy right here. Why would you do that? Why would we have a diode in what's called reverse bias across this relay coil? And the answer is that is basically a snubber. So that's going to quench the little spike that occurs not when you turn something on. When you turn something on, it energizes this coil, okay? Energizes this coil. And a magnetic field develops around this coil, just internally. It doesn't affect anything outside. And many of these are shielded anyway, but basically builds up a field of magnetic energy. And when you shut it off, what happens is when I release the switch, like this, for a split second, this coil will actually shoot out a pulse in the opposite polarity that was used to energize it. And that's because as the magnetic field collapses back into the coil, it dissipates that energy in the opposite direction. So this little quenching diode, it can be the exact same as these little silicon rectifiers like this, or it can be don't use a Zener for this, but for diodes, you would use a silicon rectifier, or you'd use a Schottky diode, and those are also silicon devices, but they have they're just made a little differently, and they have lower what's called voltage drop. It doesn't matter for this type of circuit; you can use either or. But basically, creating this OR function where either this one or this one can energize the coil. Watch. Or both. Or when one's on, the other one will still hold it up, right? But when there's no input on either side, the coil sees nothing and it's gone. But anyway, what happens is the magnetic field will collapse into this coil, create this reverse EMF kick, as they call it. And now this diode that appeared to be in backwards, it's pretty much inert when the circuit is in operation. It does nothing. Nothing at all. It doesn't interact with the circuit at all. It's only when you take the power off for that split second, the field collapses into the coil and it will go in the opposite direction. And so it's going to basically create a short circuit right here for a split second. Remember, all your other power is off anyway, so it's not going to hurt anything else. But it basically stops that reverse kick from feeding back into anything else or creating electrical noise that can bother things inside the vehicle. So anyway, it's common engineering practice to add a diode like this. There are other devices that can be used for other types of relays, contactors, solenoids. These are all kind of variations on the same theme. Some are supplied with AC, some are DC, but for this application, it's good to include a diode intentionally wired backwards so it appears to have no function to quench that. Anyway, what ends up happening is, you just saw. So in the case of my friend that has the Recaro seats, if his dome light comes on, I'm going to simulate that with this button push. Okay, this would actually be coming from his dome light. It would operate the relay. It would not feed back outside to the parking lights, which can also independently operate this relay. So either one will work. So that's called an OR function, because either of these will cause the output to go high and energize the relay, in other words. So you do want to put a fuse in here, and what I would suggest is you can see where the yellow wire, again, grabbing our simulated 12-volt car battery energy source. I've passed it to one of the relay contacts as far as the switched side of the relay. So this goes to the common side in this case. And I would put a fuse right in there, right in line. I don't have one in this example, but I do have it in the circuit. You can see that I've taken the car battery, run it directly through a fuse first before it touches anything else. It then goes to the relay, and then the relay switches that out to the load, which in this case is this little LED fan. But that's the trick there. So anyway, so you can use this again if you wanted to hook up a very large load or just something that you wanted to have isolation on. Relays serve both those purposes. They take care of the heavy lifting for the current carrying capacity to get your power to your load without going through your little decorative switches that you might want to use on your dash or somewhere else. So you can have this little tiny toggle or a little push button, even illuminated ones, whatever you want. You push one little button and it turns on just a huge array of million candle power lights, or a huge amplifier, or whatever you have inside your vehicle that you want to get power to. But that's how it works. And that's a variation on ways to use an automotive relay if you needed more than one input. And by the way, you can go down the line and actually add more inputs in the same way. Just keep adding things in parallel like this, like another diode that's parallel to all of these. Their inputs would all be independent of one another, but the outputs would all be common and supply one side of the coil with respect to ground. So that's how it works. And hope this helps. And if you have any questions, go ahead and make comments or whatever. But anyway, thanks for watching, and take care. Thanks.